Precalculus 2019 Semester 2 sample problems. They're going to be on this set of exercises 21 problems that are going to be representative of the scope and degree of difficulty of the semester test, the district semester test that's going to be given the week after next. So my recommendation for this video is don't go through it all at once. This can be a long video going into enormous detail, probably the better part of an hour. So, and I advise you to go ahead and try to work most of these problems in advance, and then after trying, to play ahead to see if you got it right. One, the graph of an ellipse is shown, and we haven't gone over ellipses yet. Over the next week, we are going to go over conics pretty thoroughly. The graph of ellipse is shown. Which equation represents this ellipse? Well, basically, I'm going to do this thing two ways, with a calculator and without a calculator. I'm going to go without a calculator first. And on your ACP formula chart, the ellipses are brought up here. And they're given a standard form of an ellipse, which could be this one here. This one here would be the A under the X, so this would be a horizontally oriented ellipse. And this one here, the B squared below and the A squared on the right is going to be more of a vertically oriented ellipse. So I think we're going to be looking at this type of situation here. So let's go ahead and look at it. Okay, so we have, we want to have the bigger term underneath here. And so the standard form, which I'm going to just copy from here, is going to be quantity x minus h squared over b squared plus quantity y minus k squared over a squared is equal to 1. So we just need to find the center. So where do we locate the center? So if we look here, if we count vertically, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this will be our center point here. So this point here is the point 1, comma, negative 2. And our h is going to be this thing here, and our k is going to be this thing right here. And so what we're going to have is we're going to have x minus 1 squared plus quantity y, and we're going to have minus negative 2, so we're going to get y plus 2 squared equals 1. And so we should be able to eliminate stuff already, like answer choice B, like answer choice D. And so now what we're going to look at is A equals semi-major axis. So our semi-major axis is going to be 5, which is half of 10. So we take the vertical distance divided by 2, we get 5. So that's our semi-major axis. So we're going to get 5 squared down here. And our semi-minor axis, we have 3, because we're 6 across. So we get 3 squared. So we're going to get, that's going to be answer choice C. And this is very easy to work out in your TI Inspire calculator too. So I'm going to go there, and to get we're going to graph a parabola, press Control I, and we add graph. We go to Menu, 3, Graph Entry Edit, and we go to Equation Templates 3, and then we go down to Ellipse. Okay, so the center form, that would be it right there, I believe. So we had y minus -2, so you just put in -2. That's going to be in at y plus 2. Then we're going to put 3 squared here and 5 squared here. So it sets it up for you, and we should get the same thing. So yeah, we get the same extent of ellipse right there. Answer choice C. Next, 2. What is the rectangular form for the curve given by parametric equations x equals t plus 6 and y equals 5t minus 3? And we see that each of our answer choices here is solved in terms of y. And so if we can take this x equals t plus 6 equation and solve that equation for t. So how do we solve for t here? If we subtract 6 from both sides, we get t is equal to x minus 6. And then we can replace this t right here with x minus 6. So we're going to get y equals 5 times quantity x minus 6. And then we got to bring over this minus 3 here. And then working below, we get y equals 5 times x, and 5 times -6, which is minus 30. And then we have minus 3. So we have y equals 5x minus 33. So that's going to be answer choice A. And this is very easy also to graph parametrically in your calculator and see which one best matches. So to do that, again, we go to our calculator. There we go. And I'm going to go Control I. We add graph. We go to Menu, Graph Entry Edit for Parametric. And so here we're going to put in 5t, x equals t plus 6. Here we put in t plus 6. And down here we have y equals 5t minus 3. Now we haven't changed the step at all, but if we just press enter, we can see the foundation of that, and we could compare graphs of each of these equations here to see which one best matches. We can see that we're going to have a really negative y-intercept way down here. It's going to be at -33. So anyway, that's it. 3, a cable holds an 80-foot pole straight upright as shown. So here we have, we'll say equals 80 feet. And based on the information, what is the approximate length of the cable to the nearest 10th of a foot? So we want this cable here. So what we have is a ratio that involves these two sides, and we will name them. If that acronym might have some old hippie, right? Or SOHCAHTOA. Okay, some old hippie is sine equals opposite over hypotenuse. So we're going to have, I'm going to write down here at the left, so we have sine of 62 degrees equals our opposite, which is 80. That's our opposite. And we want to find our hypotenuse over h, we'll say. And there are different types of things we can do. We have, if we look at our ACP formula chart right here, let's see if we can see the sine, cosine. And here it is. There's our sine, cosine, tangent. So we can see our cosecant is our reciprocal of sine. So we can have cosecant 62 degrees equals h over 80. And then we can cross multiply. H is equal to 80 cosecant 62 degrees. And we want to the nearest tenth of a foot. So 80 cosecant 62, and my calculator's in radians up here to the upper right, so I'm going to need to enter my little degree symbol by pressing this pi here and then going down there. So we get 90.6. That'll be to the nearest tenth of a foot. So h is equal to 90.6 feet. And then we can go here. We don't have, if it's plus, we don't have to. Now we need to just enter the digits consecutively. It doesn't have to be in a particular place. We could have started here at the left. So bubbling in carefully, we get 90.6. That's our cable length. Now we could use our numerical solve too. I'm going to show you this with the sine equation here. Let's do that. Again, I'm working these things thoroughly. So if we go to menu 3.1, we get sine 62, and again we're in radians, so I put the degree symbol here, is equal to 80 over our hypotenuse, our cable length. Could have used any letter. And we're going to go here, put comma h. So we get, again, same thing, 90.656. So that was our correct answer. On to problem 4. What are the rectangular coordinates for the point 5, 5 pi over 6? Well, what we have here is a polar coordinate pair. Now, it says rectangular coordinates, and once you say that, say, well, and these aren't rectangular coordinates because we're going to convert to rectangular coordinates. So we're going to have radius goes here, and the angle. Now, 5 pi over 6, I'm making a little sketch here. If we take, I'm just going to draw part of the unit circle here. 5 pi over 6 is going to be this thing right over here. Okay, so if we take an angle, standard position, come over here to 5 pi over 6. And our sine and cosine for those are going to be negative square root of 3 over 2, comma 1/2. Another way of looking at this, we can take our 5 pi over 6 and we can convert that to degrees by multiplying by 180 over pi. And we work that all out, we're going to get 150 degrees. So if you have your calculator, for instance, in degrees, you'd be able just to write x, but our cosine is x, and our sine is 1. So my calculator is already in radians, so I can just enter these like this. Or, knowing that we have this, we could say, okay, well here it is, I'm going to multiply my rectangular coordinates, is going to be 5 times negative square root of 3 over 2, comma 5 times 1/2. And for that, we're going to get 5, or negative 5 square root of 3 over 2, comma 5/2. So that looks like that's answer choice A. We can work this out, r cosine theta. So again, I'm in radians, so I could say 5 cosine okay, 5 pi over 6. We'll get that. Okay. And if we work that out, we put in negative 5 times square root of 3 and divide that by 2, we should get the same thing, right? 5 sine, okay, 5 pi over 6. Okay. In degrees, we could say 5 cosine 150 degrees. There we get that. 5 sine 150 degrees. So basically, we've worked this problem about 4 different ways. Very, very easy problem to do. Our cosine is x and our sine is 1. 5, what is the exact value of tangent negative 19 pi over 6? If I went to a unit circle, I could kind of work that out. My idea would be this is going to be radians. Okay, so you could say, well, let's go to the calculator, negative 19 pi over 6. So tan of negative 19 pi over 6. So we get negative 0.577. So we already know the answer is not positive. So we just compare these. I think we're going to end up with B. Or we could take this negative 19 pi over 6 and multiply by 180 over pi to convert to degrees. And so it'll be pi over pi. Cancel each other. So we get negative 19 times 180 over 6. So we get that angle, negative 570 degrees. So we can say tangent of negative 570 degrees. And if you're already in degrees, you don't have to put a degree symbol. We get the same thing, which is going to be the same as negative square root of 3 over 3. There we go. So that is certainly our correct answer. Where is that? There it is. Yes, answer choice B. Next. Triangle ABC is shown based on the information diagram. What is the approximate length of AC? So we want this distance over here for AC. And what are we going to use for this? Well, we don't have a right angle, looks like. So between where we don't have a right angle, we're going to have law of sines or law of cosines. Well, right now we're looking for law of sines. We want a known side opposite a known angle. So that's what we have. We have a known side opposite a known angle. And here is our law of sines someplace in here. There we go. Sine A over A equals sine B over B equals sine C over C. So we're going to use this ratio here. We're going to say 10 over the sine of 41 degrees. And we want to find this x over here, but we don't have this angle B. What do we do to find angle B? Well, B is going to be equal to 180 minus 41 minus 85. We could probably do this in our head, but we're going to use our TI-Inspire CX calculator. So 180 minus 41 minus 85. So we get 54 degrees. So 54 degrees. So we can just set up our ratio here. And so we have x here. So we have an equation we can solve. We can cross multiply the sine 54 degrees, so we get x equals 10 sine 54 degrees over sine 41 degrees. Or we could just end solve the thing here, right? Set that up. Anyway, I'm going to do this way here. So we have 10 sine, make sure we get this right, 54 degrees over sine 41 degrees. And again, we're in radians. So I got to put my degree symbol there, 41 degrees. So that's going to be AC, 12.33. So that's going to be answer choice C. And again, you could just end solve it from here. In the TI-Inspire CX calculator, let's go on to 7. If cosine theta equals 5/13 and sine theta is less than 0, what is cotangent theta? Well, what we're going to have for cosine is going to be our adjacent over our hypotenuse. So what we have for that is our adjacent. If we go right, we'll make an XY coordinate plane. So if we go our adjacent's 5, that's going to be a horizontal distance, that's going to be 5. And our hypotenuse is 13, so that's going to be this distance here. Except we know that sine is less than 0. So we're going to have to bring our hypotenuse down this way. So this is going to have to be our 13 right here. And what that means is our cotangent theta equals 1 over tangent theta. And I'll show you where that is on the ACP formula chart. Right here, cotangent is 1 over tangent. So we go back here, and we say, okay, well, tangent is opposite over adjacent. So this is going to be 12, but going down, it's going to be negative 12. How did I get that? Well, we have a squared plus b squared equals c squared. But c squared minus b squared negative 12. Well, I'm going to go ahead and so we get 169 minus 144 equals 25. That is correct. But we're going to have to be negative. For sine to be negative, we have to be going down that way. So in a tangent, we're going to have opposite over adjacent. But in cotangent, we're going to have adjacent over opposite. So we're going to get negative 5/12. Equals 5. So that's it, number 7. 8, a polar equation is used to produce the graph of the rows shown. Which equation is used to create the rows? So basically what we're going to do here is use our calculator's graphing capability for polar equations. And I'm just going to go down the list here. We can start with, here we have, that's what the thing looks like. Okay, let's get to our calculator. 2 sine, 2 theta. Okay, Control I. Add graph. Menu. Graph entry, edit, polar. So our choice A, 2 sine times here 2 theta. And we're going to get our theta here by pressing the pi key, going over here. And this is what we get. Which looks pretty good, doesn't it? Does that look right? Let's take a look at the graph. Our problem here. Okay, here's 1, here's negative 1, negative 2, and it looks like, just looking at our calculator, there's negative 1, negative 2, so not as far. So what we're going to have to do is change this thing to our other answer choice, which is going to be 3 sine 2 theta. And that's what we get, which is going to be a better match for this graph here. So 3 sine 2 theta, that's it. So this requires horizontal analysis shouldn't be too much trouble. 9, the intersection of a plane and a double napped cone is shown in the diagram. What type of conic section is formed by this intersection? You're going to be on your test given one problem that's of this caliber, where you're going to have these answer choices. You can kind of see this one slanted this way, and this thing here, what does that trace out? Well, if you're going to be directly horizontal, you're going to be tracing out a circle. But when you slant a little bit like this, you're going to get an ellipse. Also, when you go vertical, if you cut a vertical perpendicular to the base, you're going to end up with a hyperbola. And then I think the parabola is if you go at the same slant height here and just carve out like that. When you take a cross view, you're going to carve out a parabola looking thing when you look sideways. So shouldn't be too hard a problem. Let's go on to number 10. A helicopter is flying from downtown Dallas down to Florida. The distance between two cities is 32 miles. If the angle of depression from the helicopter in Dallas is 45 degrees and the angle of depression in Fort Worth is 35 degrees, how far is the helicopter from downtown Dallas? So we're going to be, we want this distance right here by the question mark. Okay. Well, I don't know how readily apparent this is, but it's going to help us enormously to find out what this thing here is. To find out what that is, we're going to have 180 minus 45 minus 35, and for that we're going to get 100 degrees. So we're going to have 100 degrees right here. And then with that, we have a known side opposite a known angle. So we're going to have 32 opposite sine of 100 degrees is going to be this distance x over the sine of this angle. We're not given this angle, but we should know from the transversal, if this is 35 degrees up here, then this is going to be 35 degrees down here. So instead of cross multiplying, I'm just going to go use my insolve, but if you will notice, I did forget something, didn't I? It's going to be sine 35 degrees. So let's do that. We go to Control I, add calculator, menu 3-1. We're going to have (32) over sine 100 degrees. And what is that equal to? Well, it's equal to a distance that we do not know, which we'll call x over sine 35 degrees. So we get sine, and again, for the umpteenth time, since my calculator is in radians, I got to be sure to remember to use the degree symbol. I come over here to the right, press comma x. There we go. So we get 18.6376. So and approximately how far? So it's going to be answer choice A. Next, problem 11. Which equation represents hyperbola with foci at -8, 3 and 4, 3 in a transverse axis that is 8 units long. I'm going to do this without a calculator first. So if we take our foci at negative 8 comma 3, so I go negative 1, 2, 3, 4, 5, 6, 7, 8, 3. So up here, negative 8 comma 3, and then 4 comma 3, so 1, 2, 3, 4, 3. So we have 4 comma 3. And it says a transverse axis that is 8 units long. So to find how long between foci, if we take 4 minus negative 8, we're going to get 12. And so we are 12 apart here, and we need to put 8 aside. Well, to get 8, we need to take off 2 here, take off 2 here. So our vertices are going to be right here at let me just write out here, we're going to have negative 6 comma 3, and here we're going to have 2 comma 3. Okay, so that's what that one looks like. And then our center is going to be halfway between these two. So we got negative 6, so we're 8. So if we go here, negative 6, negative 2 will put us 4 on either side. So our center of this is going to be negative 2 comma 3. And so that's going to be the coordinate pair h comma k to center. So we're going to have x minus negative 2 squared minus y minus 3 squared. So this is going to be, this minus negative 2 is going to be plus. So we're going to look x plus 2, y minus 3. A and B gone. And our transverse axis is going to be along the x-axis. So we are going to be, well, our transverse axis, or semi-transverse axis, is going to be 4. So we're going to have 4 squared. Oops, so we're going to put it here. 4 squared should be D. And we can put this in the calculator, see what the thing looks like, see if it makes sense. It might look pretty much the same either way. No, I don't think so, because we would get, let's see what it looks like. It's got to look right. So we go to our calculator, Control I, Graph, we go to Menu, 3, Equation Templates. We're going to go to the hyperbola, and we're going to go east-west like this. So x, it was minus negative 2, and then here we had y minus 3, and down here, oops, down here we had 4 squared, and over here we had a 20, so that's going to be the square root of 20 squared. That's weird about this. You gotta do that sometimes if you're not getting the perfect square. So we get this, and we should get, if we get this right, our foci should be, let me go here, Menu, Analyze Graph. We can analyze conics, and we'll go get a foci. And so we get -8, 3 and 4, 3. Okay, you see that? So that corroborates our correct answer of D. Next, 12. What is the exact value of the trigonometric function of cosine -870 degrees? We'll just go to our calculator. Cosine -870, and I got to put my degree symbols since I'm in radians. So -8.66. That's going to be negative square root of 3 over 2. Yeah, it's not going to be positive, it's going to be negative. So it's going to be this one right here, A. Should be a really easy one. 13. The diagram shows a boat is anchored at point B in a river. There are 2 boat ramps on the far side of the river, shown by points A and C. The boat is 120 meters from ramp A and 150 meters from ramp C. And if we have, so here we have approximately. So what you have is a side, angle side. And so we're trying to find this. We do not have a law of sides because we don't have a known side opposite a known angle. And for that, we use something called the law of cosines. And where do we find the law of cosines? On our HP formula chart, we find it right here. I'm going to use this version here. On the right, because it's most like the Pythagorean theorem. So going back here, we have c squared equals a squared plus b squared minus 2ab cosine angle C. And so we have c squared. That's what we're trying to find. C. So c squared equals, we'll say 150 is A. Let's say 120 is B. So we have 150 squared plus 120 squared minus 2 times 150 times 120 cosine of 110 degrees. And what we can do to solve for this without using again solve is we can just take the square root of this right side and get our correct answer. I'm going to do that right now. Go to calculator, control square root, so we get 150 squared plus 120 squared minus, oops, that should be 150 squared minus 2 times 150 times 120 times cosine 110 degrees. And so we get that 221.839. And we are in meters. Okay, so to the nearest meter, 221.839 is going to be, that's the nearest meter, 222 meters. So we just put in 222. So we bubble in here, 222. So that's it. Should be quite simple problem. Okay. Next, we go to a reference angle. Well, reference angles, we've gone over this quite a bit this year. And what you're looking for is the closest angle to the x-axis. To me, the easiest way for me to understand this might be to go ahead and take convert to degrees and do that. And multiply by 180 over pi. So we're going to get negative 17 times 180 over 4. So go to calculator. Negative 17 times 180 over 4. So we get that for an angle. And then what we're going to want to do is continue adding 360 to get a standard position angle. So we get that, negative 405, plus 360 again, another rotation, negative 45, and then we can add 360 one more time, get a positive angle, so 315 degrees. So we're going to be coterminal here with a 315 degree angle. So we're going to have this kind of angle here, 315 degrees. I mean, it's coterminal with that. So we are interested in this angle here, the closest angle to the x-axis. What is that going to be? That's going to be 360 minus 315 degrees, which is 45 degrees. And so we're going to have, that's going to translate to pi over 4. Now, it so happens that all these other angles are greater. 3 pi over 4 is, I think, 135 degrees. 5 pi over 4 is 225 degrees. 7 pi over 4 is 315 degrees. But our reference angle is that smallest positive angle to the x-axis. So pi over 4, which is 45 degrees. 15. Which pair of parametric equations represents a line that passes through points 2, 1, and 0, negative 3? Okay, well, this might be helpful. That's going to be a y-intercept. So that would, if we get this in solving for y, that would be helpful. And we can just go one at a time. So we can say 2. So in this case, t is equal to negative 2 over x. And then if we substitute in here, we're going to get y is equal to negative 4 times negative 2 over x plus 3, which equals 8 over x plus 3. Well, we want a y-intercept of negative 3, so that's not going to work. Nor is answer choice B going to work. Okay, so now we are between answer choices C and D. So we can just try this out. We're going to try answer choice C out. We get t is equal to x over 2. And now substituting in for t, we get y is equal to 4 times x over 2 minus 3. That's going to be 2x minus 3. So we want the point 2, 1. Well, if we say y, where x equals 2 equals 2 times 2 minus 3, so that's going to be 1. So we plug in 2, we get 1. C looks like the right answer. So you get a problem like this, it's going to take some hunting around and doing. One other way you can do this is when you solve parametrically, you can graph this. Graph y equals 2x minus 3, or you can graph these separately, see where they happen. So 2t, we'll do it two different ways, 2t, 4t minus 3. T and 4t minus 3. Graph this. See, we see our y-intercept of -3. We see up here we are at 2, 1. That looks good. Or you could take the graph that we did, that we calculated was, so Control I, graph. We can put 2x minus 3. We get the same type of deal, but this time unlimited, because we're not starting at 0. So, yeah, C is our correct answer. A little bit of working around on this. 16, Harrison walks the library after school every day. When Harrison leaves school, he walks 16 blocks due west, then 12 blocks due north. To get to the library, what is the magnitude and direction results in vector? So we come like this. So Harrison is walking direction, so we can just set this up east, north, west, south. So Harry is going 16 blocks due west, so this is going to be 16 right here. And then 12 blocks due north. So here we have 12 north. Okay, so we want to have this angle here and this distance. Well, for distance, we're going to have 16 squared plus 12 squared equals c squared. So 16 squared plus 12 squared, 400. Okay, so we have 400 is equal to c squared. If you take the square root c, it's going to be equal to 20. So if you didn't notice, this is a multiple of the 3, 4, 5 right triangle. And so our magnitude is going to be 20 blocks. And what about the direction? It's going to be west to certain north. So we're going to say our direction is going to be tangent, or inverse tangent of 12/16. So inverse tangent of 12/16. But I'm in radians, so I multiply by 180 over pi. I should get my degrees. Put the wrong one there. Pi. There we go. So 36.87 or 36.9. Where do we see that? Right here. Answer choice B. Next. 70 hyperbola has foci at -1, 2 and 13, -2 and an eccentricity of 7/6. What is the equation of the hyperbola in standard form? Well, this is similar to that one we looked at earlier. We can sketch it out. So here we have an XY coordinate plane. So we have -1, -2. So that's -1, -2. And then over here we have 13, -2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, -2. And we have eccentricity of 7/6. So we call this E is equal to 7/6. How do we make something heads or tails out of that? Well, let's go take a look at things here. If I fail on this, I'm just going to go to the calculator and plug in until I get. So we go to a hyperbola. Eccentricity equals C/A. So eccentricity equals 7/6. So 7/6. C/A. So A should be 6. So we should be 6 squared. Where is the center of this going to be? Well, it's going to be halfway between 13 and -1. So if we go, let's see, that's going to be 14 apart. So this will be 7, 1, 2, 3, 4, 5, 6, 7. So this will be our center, which is going to be at 6, -2. So we're going to get, if that's going to be h, k, that's going to be x minus 6, y plus 2. So it could be that. Okay, so it's definitely not going to be these guys here. We can just try this and see if we get the right foci. X minus 6 over square root of 36. If it's not, we can try this one here. It'd be pretty easy to get. So yeah, let's just go to calculator at this point. And the eccentricity, we're going to get 7/6, which is going to be 1 point something. So here we go. We go to Control I, Add Graph, go to Menu, Graph Entry Edit, Equation Templates. We're going to go to Hyperbola. We're going to go East-West. We're going to go X minus 6. And over here, I want to make sure I get this right. Yeah, -2 minus -2. And here we had 6 squared. Over here we're going to have square root of 13 squared. And that gives us kind of what we're looking like. We don't see quite the totality here. If we change our window settings, I'm going to increase our X max here to maybe 14. That'll help us see things better. So there we can see it. Now we can go here and we can go to our analysis tools. We're going to look for eccentricity, analyze graph, analyze conics, eccentricity, there we go. And we get 1.166. 1.1667. So our calculator, what is 7/6 going to be? There it is, 1.166. That's it, my friends. That's it. So choice is D. Next, 18. Which graph represents the curve given by parametric equations x equals t squared minus 3 and y equals 2t over the interval from t equals -3 to 3? One thing you're going to have is t, the arrows here in a parametric curve always go in the direction of time. So here in choice A, we see time starting at -3 and going to 3. So that would be possible. Here on answer choice C, we're starting t but going the opposite toward -3. That cannot be right. In B, we're starting here at t equals -3. The arrows go from 3 to -3, not the right direction. So at this point, we are between answer choices A and D. So let's just put the equation in our parametric equation in our calculator and see what she says. And for that, let's go to calculator, Control I. We go to Add Graph, Menu, 3, 4, Parametric. The first one we're going to put here is t squared minus 3, and then 2t. And down here 2t. And then we want to go from -3 to 3. So we go over here, t equals -3 to 3. And we can just leave that t step here. That'll be just fine for what we need to see. So here we have it. So it's going to look just like the graphs of A and D, but what we need to find is what is the direction. That's going to be the distinction between these two. Is the thing like choice A going up from down here or down from up here, choice D? So we can go and trace. If we go to graph trace, we can just arrow to the right. And we can see that time is putting us in this direction up here. So we are going to start, our arrow going this way is our correct answer. So let's go to see which one that is. Yeah, it looks like answer choice A. Let's just verify for sure. Looking back, see, look at T. T is 1.3. If we arrow to the right, we have T increasing as we're going like this. So that is correct. Okay, next, 19. If U equals 8, 12, -3, V equals -4, -7, 14, and w equals 2 comma negative 5 comma 6, what is 3u minus 4v plus 2w? And what we notice is that for this first component, all these are different. Each one of these is different, meaning that if we just analyze the first part of it, we're going to figure things out. So we say u is equal to, well, 3u, let's do that. 3u is equal to 3 times 8 comma 12 comma negative 3. And just working to the right, if we distribute, we get 24 comma 36 comma negative 9. Okay, and says 4v, so 4v is equal to 4 times negative 4 comma 7 comma 14, and that's going to be equal to 4 times negative 4 is negative 16, comma 4 times 7 is going to be 28, and the last one, 4 times 14, should be 56. And then finally 2w is equal to 2 times 2 comma negative 5 comma 6, and that's going to be 4 comma negative 10 comma 12. And then when we get our answer down here, which we can work out, is we have 3u minus 4v, so it'd be 24 minus negative 16, so that'd be 24 plus 16, which would be 40, plus 4, so we get 44. So already we know our correct answer, don't we? We know D is our correct answer. But for extra assurance, we just go ahead and continue to work this out. We have 36 minus 28, that should be what, 8? And 8 plus negative 10 should be negative 2. And then the last one, we have negative 9 minus 56. That's going to be negative 65. And negative 65 plus 12 is going to be negative 53. Okay, that's it. 20. If r equals negative 4 comma negative 2, the vector which graph represents negative 2r? So this is going to be, so negative 2r is going to be equal to negative 2 times 4 comma negative 2, which is going to be equal distributing negative 2 times 4 is going to be negative 8, and then negative 2 times negative 2 is going to be 4. So we want that vector, negative 8 comma 4. That's going to be negative 8, negative to the left, right. So that's going to be answer choice C, negative 8 comma 4, right here. There it is. So one thing I'm doing is I'm checking on these with the answer key a little bit to make sure they see things the same way I do. They do in this case. Okay, the last one in this exercise set is 21. What is the reference angle for angle that measures 300 degrees? So this one is like that reference angle problem we had earlier, but much easier, because we have 300 degrees here. So here's our ray at 300 degrees, right? Here's our initial side or terminal side, 300 degrees. So what we're going to have are, by the way, reference angle is never greater than 90 degrees. So what we're going to have is our reference angle is going to be 360 minus 300 degrees, which equals 60 degrees. Very easy problem. Well, that, my young friends, or maybe some of you aren't so young, that's it. I hope this will help to you. Good luck, and thanks for viewing.